in this tutorial we're going to be seeing what object-oriented programming is. Now the reason we're going to be doing this or seeing this is because Java uses object-oriented programming. So it's to give you a better background of the inner workings on how and why Java works and also on its design. So object-oriented programming, also known as OOP as an abbreviation, is a programming language model organized around objects rather than actions and data rather than logic. So to best represent this using an analogy, say you wanted to assemble your own PC. You go to your hardware store, you pick up a motherboard, a processor, RAM sticks, hard drive, power supply, etc. Obviously all of these parts have to be compatible with each other, but just for the sake of argument, let's say that's not an issue here in this case. So you put them together, you turn on the power, and your PC runs. In the same fashion, a car, for example, is assembled from parts and components. So a car has a chassis, doors, engine, wheels, brakes, transmission, and whatever. So these components are reusable. So in the case of a car, a wheel can be used in many cars, obviously of the same specifications. In the case of a PC, you can take I don't know, the processor out of this first PC and use it in the second one. So hardware such as computers and cars are assembled from parts which are reusable components. So how about software now? Can you assemble a software application by picking a routine here, a routine there, and expect the program to run? Well, obviously the answer is no, you can't. So unlike hardware, it's very difficult to assemble an application from software components. So this is where object-oriented programming comes into play. Object-oriented programming languages are designed to overcome these problems. So the basic unit of an object-oriented programming language is a class, which encapsulates both the static properties and dynamic operations within a box and specifies the public interface for using these boxes. So here we have a diagram of what an object-oriented program would look like. So as you can see, you have classes or boxes that are well encapsulated, and inside them you have attributes, and behaviors. Now all of these objects are interacting with each other by sending messages. So since classes, remember this is a class, the box here, are well encapsulated, it's easier to reuse these classes. In other words, object-oriented programming combines the data structures and algorithms of a software entity inside the same box. So as an example, suppose you wanted to write a computer football game, which is represented here, or the classes are represented here. It's quite difficult to model a game in procedural-oriented languages, but using object-oriented languages, you can easily model the program according to the real things that appear in the game. So, for example, we have the classes here: player, ball, field, referee, audience, weather, scoreboard. So for each class, as I said, as above, you have attributes. So for the example of the player, it would be its name, the player's name, the player's number, the location on the field, etc. And you would have the behaviors of that class, which would be, for example, running, jumping, kicking the ball, etc. And you would have the same kinds of attributes and behaviors for each of these classes. So most importantly, some of these classes, such as ball and audience, can be reused in let's say another application. So I don't know, a different kind of computer game, let's say for basketball, with little or no modification. So that's the principle of object-oriented programming. Object-oriented programming relies on three main principles. Now these principles we're going to be seeing in detail in the next couple of videos, so I'm just going to give you a broad definition of them. So first we have something that's called encapsulation. Now this limits the access that other pieces of code have to a particular object. Now then we have the principle that's called inheritance. Now this refers to a superclass and a subclass. And then we have polymorphism, which is going to which lets you take an object, or lets an object take on several forms while your program is running. Again, these probably don't mean anything to you at the moment. They will be looked upon in detail in the next couple of videos. So this is just to give you a broad idea of what object-oriented programming is, and we'll see in the next videos how it applies specifically to the Java language.